This is a video, an animation, that's going to visually show you how bacterial locomotion works in terms of the structure of the flagella and how it's going to move on the bacterial cell. So there's some specifics that I'm not going to ask you or require you to know in terms of things like how long is the bacterial flagella or the specific rings on the basal body. We're not going to get that in depth about it, but you do need to, I recommend watching this video. It really will visually help you understand what's going on.
Most motile bacteria move by means of flagella. A flagellum is a slender structure about 15 to 20 microns long and about 20 nanometers wide. A typical rod-shaped bacterial cell is 2 to 3 microns in length. The bacterial flagellum is composed of 3 parts: the basal body, which is embedded in the cell membrane and wall, a short curved segment called the hook, and the portion that extends out from the cell called the filament. The basal body consists of rings that correspond to the layers of the cell envelope and therefore differ in gram-negative and gram-positive bacteria. In most gram-negative bacteria, there are 4 rings connected to a central rod. Gram-positive bacteria have only 2 basal body rings, one connected to the cell membrane and the other to the cell wall. Motility is mediated by proteins associated with the plasma membrane.
I'm not going to ask you to label the proteins and get detailed in terms of how specific all the flagella moves in terms of its physiology and how it functions. What I do want you to be familiar with, or at least recognize, is this proton motive force down here is really what is causing that movement. That proton motive force is just the movement of hydrogen ions across the cell membrane. So it's going to give it energy to rotate. And we will talk about the proton motive force again when we talk about cell metabolism and making energy.
And basal body, and is powered by the proton motive force associated with the plasma membrane. The filament is a rigid structure which rotates to move the bacterial cell. Spirochetes are motile by means of bundles of flagella, called axial fibrils, that run along the cell within the periplasmic space.
So we haven't talked periplasmic flagella or axial filaments. In this animation, they're calling them axial fibrils just yet. However, this gives you a good visual representation of what's going on and how they work. So you'll have a better understanding going into that slide in just a handful of slides in terms of what we're going to talk about.
The number of fibrils varies. These axial fibrils extend from both ends of the cell within a flexible outer sheath. Spirochetes have a screw-like motion which allows them to bore into mucoid layers and soft agar media. Some bacteria...
I want you to stop here. We're not going to worry about how gliding bacteria move. It's not something we're going to talk about. The only 2 forms of motility or locomotion we're going to really worry about in this class are the basic flagella, and in the corkscrew, your spirochete organisms, the periplasmic flagella or axial filaments.